Welcome to our next part of this video about converting a continuous function into a step functions. So, as for review, what we discussed last time is how we can convert a real number function into a desired length of steps. So we have h represent the desired length, and as we can see, we can extend the length of this step function depend to our desired. Okay. So this time, let's say for example, we have a continuous function. We'll try to change this one into a linear function, a linear continuous function. So if you remember, on a linear continuous function, we have mx, we have this m represent the slope plus the y-intercept. So we have y mx plus b. So we'll try to make a slider for both of this scale, and we can see we have the slope is 1 and the y-intercept is also 1 on the y. So we can see we have 0 1 as y-intercept. So we'll try to change this one into 0 so that we can have it on the center. Okay, good. So now we can just change the slope. That would depend to us. You can put it very steep, or we can make it negative like that one. Okay. So since we have already the idea of how we can convert a real number into a step function with the desired length of step, which is h, so which is here, we have here like this one. Okay, so this time we will try to substitute this value of f of x. Okay, so we'll try to rewrite again new functions that would convert this linear mx plus b into a floor function. So we have f of x is equal to the slope. Okay, so we'll try to copy the same rate of slope. So we have m. Okay, then the real number x will be converted into a certain length of step, which is the h. Now we can see that the h is 2 units. Okay, so meaning I will just multiply this h integer of x over h. Okay, so we have right here. So we'll try to use this one. I will just use this one h, and we'll try to use the floor function. One, floor of x divided by h. Okay, so we can see. Okay, good. Okay, now we can see already that the slope of this function here is already the same on the original function mx plus b, wherein the slope is 2 and the y-intercept is 0. Okay, and of course I will try to add that y-intercept b. Okay, so every time I try to move the position of b, the steps will also try to follow. So we'll try to check. So the changes that we have, that we have converted this linear function into a linear step function, is just simply using this h floor x over h, converting that one into this step function. So if I will try to remove that one, okay, so we have now this function. Okay, I can also try to increase the step, but the slope will remain the same. And I can also try to move the y-intercept based from the original continuous function, like that one. You can move it to the negative, you can move it to the positive. Okay, now we have converted this kind of linear functions, you can see, into a step function with the desired length of h. We can have negative length of h, we can also have the positive length of h. Okay, so we have just converted the linear continuous function into a step function. Okay, so thank you so much for your time and hope to see you to the next conversion of functions. This time we'll be moving into the quadratic and cubic function. Thank you so much and see you right there.